So for today we're going to talk about compound loci in coordinate geometry. So we're going to review some algebra real fast. If you have a line x equals a, where a is a constant, like x equals 5, x equals -5, that type of line is going to be a vertical line. And vertical lines are always parallel to the y-axis. And if you've got a vertical line, it has no slope. No slope is the same thing as undefined. Okay? Now if you have a line that's y equals a, where a is still a constant, y equals 5 or y equals -5, those types of lines are horizontal lines. Horizontal lines are always parallel to the x-axis, and horizontal lines has a slope that is 0. So it has slope of 0. No slope is very different from slope of 0. This is from the other unit. All parallel lines have the same slopes. All perpendicular lines have negative reciprocal slopes. One thing just to know, and I think you probably know this already, any vertical lines are always parallel. Any horizontal lines are also parallel. So what we're going to have to do now is graph and describe each locus, finding equations wherever we can. So we want to find all points that are 5 units from the line with equation of y equals 3. Well, we're looking for this to be our given, and if we go for y equals 3, I know I've got a horizontal line up at y equals 3. So I've got this horizontal line. This equation is y equals 3. I want to find the equation of the locus that are 5 units away from this line. Well, 5 units away would be 2 particular parallel lines, one above, one below. So I'd have to go 5 units above, 1, 2, 3, 4, 5, draw my line, go 5 below, 1, 2, 3, 4, 5, draw my line. Well, these guys have equations also. They are also horizontal lines. The equation up here would be y equals 8. The equation down here would be y equals -2. So the loci are 2 lines at y equals 8 and y equals -2. We've sketched it, we've labeled them, we've described them. Next one. Find the locus of points 3 units from the line whose equation is x equals 5 and 2 units from the line whose equation is y equals 4. Well, let's do these a little bit separate. Let's do them separately. So the first given equation is x equals 5. X equals 5, I know, happens to be a vertical line, 1, 2, 3, 4, 5. So here's x equals 5. Whoops, you don't have to label it that way. So there's x equals 5. And now I also have a given line that is going to be y equals 4, but I'll do that one in a second. Let's look at the x equals 5 for a second. I want to be 3 units away from x equals 5. So I better have 2 more vertical lines parallel to this, and they're 3 units away. So 1, 2, 3, and then 1, 2, 3. So these loci happen to be x equals 2 and x equals 8. That's the first condition. The second condition is I've got to deal with an equation whose y is equal to 4. So I'm going to go to y equals 4. So here's y equal to 4. I want to now draw loci that happen to be 2 units away from y equals 4. So if I go 2 above and if I go 2 below, these two equations are y equals 6 and y equals 2. Well, my two sets of loci do intersect, and they intersect at 4 distinct points. I'm going to label these points A, B, C, D, and my description is going to be the loci are 4 points. We need to be very specific, though. Point A has ordered pair 2, 6. Point B has ordered pair 8, 6. Point C has 8, 2, and point D is 2, 2. So be as specific as you can. Next one, last one. We want to find all the points in the coordinate plane 6 units from the origin and equally distant from the x and the y axis. So if we do a 6 units from the origin happens to be this point right here. Clearly not oriented. Let's try to move up a little bit. Okay, so from there. So I'm going to create a circle that's going to be 6 with a radius of 6. So I'm going to use my circle tool here. Now it's not going to be perfect. It's not going to be dotted, but I know I'm going to start 1, 2, 3, 4, 5, 6. This should be dotted. It's not, but it should be dotted. And now I need to be equally distant from the x and y axis. Well, you need to understand that the x and y axis happen to make an angle, and a right angle for that matter. And there's 4 different right angles. The 4 quadrants are right angles. Do I erase the circle? No. So the 4 quadrants are right angles. So what you need to be able to do is realize that if from sides of an angle, I'm going to be the angle bisector, which means if I were to try to sketch my angle bisector of this quadrant, I'm going to actually go all the way in the top and all the way down. So I've got that line, and then I'm also going to have this angle bisector. Well, these angle bisectors have equations. Remember, the equation of a line is y equals mx plus b. Both of these lines start at the origin. So they both have a y-intercept that's 0, but then each line has a slope of 1. To get from one point to the next, I'm going to go up 1 and over 1, or I'm going to go down 1 and over 1. So this line happens to be slope of 1, y equals 1x plus 0, which we would just say y equals x. This guy over here has y equals negative 1x plus 0, or y equals negative x. So the equations of both of these lines would be this and this. Well, the real question says, though, it's what's the loci? And the loci are going to be these 4 points of intersection. It's going to be a little bit harder with a circle to have a specific ordered pair, so we're going to approximate our answers, so approximate answers. And we're going to have A, B, C, D. Well, it's going to be 4 points. Ordered pair A looks like it's over 1, 2, 3, 4, up 1, 2, 3, 4. And again, you might be off just a little bit. Whoopsie, negative 4, positive 4. B looks like it's over 1, 2, 3, 4, up 4. And then everything is going to really be in this 4, 4 category. C then is going to be right 4, down 4, and D is going to be left 4 and down 4. So those are your 4 sets of ordered pairs, and they're approximate. Again, with a circle, it's a lot harder. So we're going to approximate the answers. And that's it. Okay, so be very specific with your graphs, label things where you can, and then you should be all good.